Wish you a very happy new year and good afternoon on behalf of Tata Steel. This is Sanjay Behra, Head of Marketing from Tata Strom. I thank you all for joining us at this webinar today, which is energy saving opportunity in your businesses. We are happy to have with us Mr. Prasanto Pal of TERI, a leading think tank dedicated to research for sustainable development and promoting clean energy, water management, and pollution management. Nearly 600 small and medium enterprises in India have adopted a range of energy efficient technologies and practices promoted by leading organizations like TERI. These technologies applied in key industries such as foundry, glass, forging, engineering, brick making have altogether reduced energy consumption by 2 lakh tons of oil equivalent. From homes and offices to the shop floor, energy efficient technology can impact the bottom line with impressive cost saving. So, switching to energy saving bulbs, turning off the air conditioning when not in use are simple energy saving methods that we know about in our normal day to day life. But there is much more to investigate and how to efficiently use and maintain plant and equipment, how to replace outdated machinery with new energy efficient technologies, and much more. We are here to learn how we can adopt and integrate energy efficient technology to cut wastage, improve productivity, and improve our cash flow. So, over to Mr. Prasanto Pal. In case you have got any questions during the webinar session, we request you to type your questions. He will be glad to give a suitable reply. Over to Mr. Prasanto Pal.
Yeah, thank you, Mr. Vera. Yeah, good afternoon to all of you and Happy New Year to all of you as well. Welcome to the webinar, and also at the outset, let me all wish you a happy Lori, which is today, and of course, Makar Sankranti tomorrow. It's a festive season this weekend with Pongal also following. Well, the topic today is on energy savings, and I'm sure all of you are entrepreneurs having own industry and understand the importance of energy saving, because energy particularly is something which is an invisible cost, because and it makes enough sense because you normally look at manpower savings, raw material savings, and energy is usually overlooked because it's invisible and you pay the bill at the end of the month. So hopefully I can share with you some tips of energy saving during the course of my presentation for the next hour or so. I would be covering in the presentation essentially would be I'm from TERI, as Mr. Behra mentioned, and I'll tell you about TERI and its activities related to MSMEs in particular. Then I'll move on to some of the common areas of energy saving in your industry, typical industry, and then I will move on to talk a little bit about use of energy audit tool as saving energy in the plant, and finally ending with some case studies for actual implementation of energy saving technologies in a plant. Particularly, all are the case studies I've selected are from SME units. The TERI and what is the areas of activities in particular in MSMEs. And TERI, I would like to also tell you at the upfront, as it shows, is a non-for-profit. It's an independent research institute, and we were actually promoted by the Tata group of companies way back in 1974. And now we, from a very modest beginning of about 10 people, we have about 1,000 people located at different locations. Headquarters is in Delhi. As you can see, we have got offices in Bangalore, Goa, Mumbai, and Guwahati, and field offices in Gwalpadi, which is near Gurgaon, and Mukteshwar. And also about in 1998, we have established the TERI University, which is an independent setup based in Vasant Kunj, where we offer postgraduate and postgraduate degrees and PhDs on energy efficiency and sustainability. Now, our focus of work in TERI on energy are essentially can be divided to three broad topics. One is the detailed energy audits, which I'll talk more about. But other activities, as most of you are from SMEs, you can understand that there's a need for developing new technologies, because this is something which has not been neglected, and many of the technologies use furnaces or processes which are quite antiquated, very old. So there's need for new research, development, demonstration, and dissemination. It has been a focus, and we have been fortunate to work in some few sectors like foundry and glass industry. And the other activity in TERI has been on knowledge sharing, and we have actually a web portal called Samiksha, and the which is actually small, stands for Small and Medium Enterprise Energy Efficiency Knowledge Sharing Initiative. So the website is called samiksha.org, and you are most welcome to come and visit and see some case studies which we have placed, and also share good practices which you may have in your plant through the website. Uh, Now coming to audits, well, energy audits is one of the main activities in our group, as I said, and we have been the pioneers in energy audits. We have done more than 1,500 detailed audits, and I'll come to this because when you say detailed audits, it's a bit different from preliminary audits, which many times is, I mean, there's a need to be segregation with detailed and preliminary audits. And typically, an audit covers activities like electric motors, boilers, furnaces, air compressors, air conditioning system. All the energy intensive, energy guzzling equipments in the plant are covered in scientifically to study and come out with techno economically feasible recommendations. And for detailed audits, we use a host of online measure portable instruments which we have, and I'll come to that. For example, this photograph shows our measurements which we have been taking in a plant. Uh, so it's again a rolling plant, steel rolling plant in Indonesia. Now, very briefly coming to the new developing technologies, development of cleaner technologies, as I mentioned, and we entered into this space because MSMEs are a very important segment, as you all know. There are roughly about 49 million SMEs as per government records, involving more than 111 million people. So they provide a huge majority of jobs. It's the next largest employer after agriculture, and it contributes to the manufacturing output. I mean, hugely, almost 37% of the manufacturing output. But what is unique about many of the sectors, traditional, particularly when it are traditional sectors, is that, like, for example, secondary metallurgical processes, iron, steel rolling, aluminium melting, casting, and so on, and glass industries, textile, and so food processing, they use a lot of processes of furnaces which are very old and antiquated. So there's been need for development and innovation, and in this aspect, what we have done is we have actually worked with international experts jointly to develop a few cleaner technologies for SMEs, and then after we have developed it, we have demonstrated it at a unit level, and then we have helped replicate it through the cluster associations in different clusters. And some of the initiatives, largely most of these initiatives have been supported by the Swiss government. There's an agency called Swiss Agency for Development and Cooperation, and we have been actually received the support to work on this. I'll show you an example of two clean technologies which we have developed and demonstrated, just to give you a flavor of that. Uh, this is a photograph of a cupola furnace which is used in a foundry for melting iron. And traditionally, this is the furnace is bought, developed, designed by the local mistri, and it can be just and every foundry, there's no standardization of the design. Every foundry uses its whatever the design the mystery gives. So there's what, and obviously using a very high amount of coke consumption, very inefficiently operated and run. Here we have demonstrated a new furnace design called divided blast cupola, and it's a properly designed divide blast cupola. I mean, you can just see the comparison between before and after situation in the same foundry. And this foundry, which is actually in Rajkot, has six of these cupolas operating, and all have been designed by TERI. This photograph is actually of a glass unit in Firozabad cluster. It's a bangle making unit, and you can see the before and after situation here also. They were using a coal-fired pot furnace before, and now because the coal is banned in the Agra region, and this was replaced with a natural gas fired pot furnace with the top firing. The burner is the top, and you can see the dome, which is like the construction of the dome itself was an, I mean, quite a technique which we had to, develop and also tell them. The dome with this construction actually lasts about a year. Earlier, the dome used to break within a few months, and every few months they had to have a shutdown to build the dome. And it is having recuperator for, I mean, which you can't see actually. It is an underground recuperator heat exchanger to so the heat exchanger between the off gases and the fresh gas, the combustion air which is going into the burner. So this is about these are two technologies on R&D, and finally I'll come to the knowledge sharing. And this is a snapshot of the website, Samiksha website, which was set up 6 years back. And what we do try to do is synthesize and pool knowledge about energy efficiency topics in this. And I would encourage you to come and visit this and participate more actively. I mean, in this, I'm sure there's a lot of learning to be had in this through this also. Now I'll move on to the energy saving aspects in an industry. How, and before that, why save energy? Why energy efficiency is important? Of course, energy efficiency. I mean, typically it's Let me try to also tell you, like, it is energy efficient technologies and energy conservation is sometimes mixed. Typically, energy conservation is about talking about best practices, like, you know like switching of the motor or switching of the light at the proper intervals. Energy efficiency is introducing a new efficient technology, saving energy through introducing a new technology or improving it. And it has been found that energy efficiency is the most cheapest and the most cost effective way to reduce carbon dioxide emissions. As you know, carbon dioxide emissions causes global warming. So through that, this has been now well documented through international agency, energy agency, which is in Paris, has recommended that carbon dioxide can be saved up. I mean, at least 50% of the measures to save carbon dioxide should be through energy efficiency measures. Apart, there are other ways to save carbon dioxide, like solar energy, wind energy, and so on. But if you see the payback on investment, this actually shows that energy efficiency improvements actually have a fastest payback period. As this is the table shows, it is between 2 to 5 years usually. Whereas if an investment on solar and wind without a subsidy is 10 years plus return. So in terms of payback on investment, energy efficiency is definitely attractive. Now, typically when we talk of energy savings, this chart shows there are different levels in a plant. So one can save energy in the process equipments. The next is cross-cutting technologies, that is the auxiliaries or the utilities in the plant, like the pumps, fans, compressors, air conditioning, motors, and I'll talk more about these utilities, saving in that. The third approach could be using a fuel switch option, using natural gas if it's cheaper, or a biomass, I mean wood, or some, in the boiler or so on, wherever it's feasible, because these are also less of these are less carbon requirement than the conventional fossil fuels. And recycling also would save. I mean, recycling and use of secondary materials would save energy as well. Now, I would like you to pay particular attention to this table, and I'll go through it in a bit more detail. Now, typically in a plant, there are, as I mentioned, there are two main process areas and plant auxiliaries. Now, within these two areas, one can save energy at three levels. At the outset, the cheapest or the most easiest is good practices or better operation of the plant. So things like, for example, in the plant auxiliary, reducing compressed air leakage or steam leakage in the plant, or any leakages or some housekeeping measures kind of thing, if we call it. In the furnace, if it's there, so better operation of the furnace. So these are housekeeping. It does not require any capital investment. It can save energy. The second level is retrofit. So here you can actually retrofit or install a piece of equipment to along with the existing equipment. This example here gives a variable speed drive. So VFD is installed, let's say, along with the motor or a compressor, so to save energy. And or in a furnace one can install a waste heat recovery device if the furnace temperature, outlet temperature is there. So these are retrofit without changing the equipment. Obviously retrofit costs a bit more than the housekeeping measure. And the third level is where you completely replace the existing plant equipment with a new energy efficient equipment. So this is obviously the most costliest of the three levels, but the level 3 would lead to more energy saving. It will highest amount quantum of energy would be saved if you install, if you are able to replace it with a more energy efficient equipment. Now, in my presentation, I would like to give you examples from all these three levels and would encourage you to ask questions. I mean, when I go through the case studies, or if you have any, I mean, please, you can type in the questions at any point of the time and I'll be happy to respond to that. Now, before I go into the energy saving options in your plant, I would also like to mention about energy audits. Now, because to my mind, energy audits are a scientific way of analyzing energy consumption in the plant and to find out where you can save energy. When we talk about audits, essentially, as I said, it's a scientific way to save energy, but it involves the following steps. First step in audit is to monitor the energy data in the plant. Now, this could be using portable instruments which the auditor may use, or using your data, company data, which is available if the auditor is not having their own instrument. Then uh, once you have this monitoring of energy data, second level obviously involves the analysis of the data and to calculate the efficiency of equipment. If it could be efficiency of the motor you are using, efficiency of the boiler or the furnace, efficiency of the air compressor, DG set, whichever equipment one is doing the audit for. What is the operating efficiency? Comparing that operating efficiency with the design efficiency or best available equipment with the highest rated efficiency which is there in the market, and then doing the cost benefit analysis. How much or what is the operating hours, how much energy is saved by using this equipment, how much is the cost, and then what is the payback. So that is how the recommendations, energy saving recommendations, are arrived at in energy audits. And usually our practice is to give recommendations which has a payback of 2 years, so which is very attractive usually, as you can see from understand from your company. If you have a payback within 2 years, you are extremely attractive, because after 2 years the equipment is paying you the return for the energy savings, and you are getting a return on investment. But on the energy audits, I would also like you to, there's a word of caution, because many auditors or many people are doing preliminary audits, and there's a difference between doing a preliminary audit and a detailed audit. Preliminary audit usually is a walkthrough kind of audit, 1 day, half day kind of visit to the plant, collecting the data, coming out with a report, and coming out with very generic recommendations. So one of the grievances of many units or SMEs is that the energy audit report cannot be implemented. I mean, that is precisely the reason. If you have done a preliminary audit by the auditor has given you a very standard recommendation like lighting and all, so I mean it doesn't give much more than what you already know. The uh, other extreme, what is required is probably a detailed audit, and obviously the word detailed here is the key, because a detailed audit would involve analysis of data or monitoring of the energy data in the plant for considerable amount of time, using the portable instruments. So it is and then analyzing the data. So usually a team of 3 to 4 auditors visits the plant for about a week or so, then goes back, prepares the report. The report gives the energy saving, what is the investment, what is the payback. So based on the investment payback, the unit can actually take decision on the investment, and this could be, even the report could be submitted to the bank for availing loans, energy efficiency loans. As you know, some of the banks also offer energy efficient loans like SETB and all. And there are some government schemes which give energy efficiency loans on this as well. So you can avail of those through the banks for your unit. Now, typically in an audit, the auditor looks at the following: furnaces in your plant, air compressor network, refrigeration air conditioning system, pumps, fans, blowers, cooling towers, transformers, lighting, motors, DG sets, so on. I mean, these are the major. Of course, it can be customized as per the plant requirement, but these are the major equipments which are audited typically by the auditor. And as I mentioned, the equipment, energy auditing equipment plays a critical role in that. And I'll just show you some of the energy auditing equipments which I used, just to give you an idea of the kind of instrumentation which goes with the detailed audit. For example, this is thermocouple to measure the parameter, and it can temperature, and it can measure temperature to 1 decimal place. So this is a digital thermometer. This is one of the key for many of the audits. This is actually to measure the flow of water. This is, for example, flow of the chilled water or in the refrigeration air conditioning chillers. This has got a range. As you can see, it can measure from half meter per second to 12 meters per second, and an accuracy. It can measure plus minus 3% accuracy. This is one of the most important equipment which is used by the auditor. So this is to measure the power parameters like voltage, power factor, current, and so on. All the voltage parameters can measure. This is a three-phase power analyzer having a range of 200, 2 to 2000 ampere and accuracy of plus minus half a percent. The another equipment is a tachometer, and this is to measure the RPM of the fan or the motor. And one of the critical equipments here is also the flue gas analyzer. This is particularly for the furnaces to measure the oxygen or the CO or CO2 of that, and to find out the excess here in that. I don't know how many of you are actually using a furnace which is having oil fired. This is particularly for oil fired furnaces or boilers, which is the most useful equipment. Now I'll move on to sharing with you some of the case studies, and please feel free to type in your questions as we come and go through some of the case studies through that, because essentially this is to give you a flavor of the energy efficient practices and equipments which can be undertaken in the plant. Now I'll come firstly to the good housekeeping, the level 1 measures, because this is low cost measures, so which can save energy in the plant. I'll start with some of the measures for air compressor and compressed air network. But before that, this particular slide shows how important it is to have save energy. For example, in the air compressor, it's one of the most energy intensive equipment. Actually, compressed air is like the considered a utility. Actually, it should be considered a utility, and most plants consider it like a utility. Like you have electricity, fuel, oil, water. So compressed air is like a utility. As you can see, it's very expensive. 1,000 CFM air compressor, which is can uh, the equipment and running for 8,000 hours in a year could lead to electricity bill of 76 lakhs. So it is almost 3 to 4 times the cost of the compressor equipment itself, the running cost of the air compressor. And here there are many tips for saving energy. One of the most important is to operate the air compressor at the right pressure, because if one kg increase, 1 bar increase in the air compressor pressure actually increases the power consumption by 4 to 5%. Not only it increases the power consumption, it also increases the leakages, air leakages in the plant by 10% or so. So it's the first thing is at what pressure you are operating the compressor and what pressure you are using the air. So should try to match that, maybe half a bar more or 1 bar more, not more than that. This is the and we have done audits in many plants, even large plants also, where they usually they operate the air compressor at the pressure which has been set at the time of commissioning. They have never bothered to check whether they require that much pressure at all in the plant or not. So this is one of the most common areas of energy saving. This photograph actually shows about air leakage, and I can tell you, like most of the plants, almost all the plants we do energy audits, this is the area where the maximum amount of energy saving can be found, and absolutely at no cost one can save energy, because you know in this plant, as you can see, all the joints, flexible joints, or even the pipeline, I mean, these are typical areas where air is leaking. In fact, in some of the plants we have audited, we have found the air leakages are almost to the level of 40%. So 40% of the loading in the compressor is just meeting the leakages in the plant. You can actually reduce 40% energy consumption in the air compressor by probably cutting it down to 10%, 30% reduction in air in the energy load in the compressor by reducing the leakages, simply identifying the leakages. And you don't require an auditor or an expert to do that. Probably, I mean, the best way to do identify leakages is operate the air compressor, and probably when the plant is under shutdown or at night when the machines are not working, it is very easy to detect all the leakages in the plant, and one can just identify the leakages and plug the leakages by either clamping or putting a clamp or changing that part of pipeline and so on and so forth. The second aspect or energy saving area in a compressed air network is to design the compressed air pipeline. Now, this photograph actually taken from one unit which we did the audit. You can see a large number of bends. To take the compressed air line to the usage point, he had provided unnecessarily 4 bends, whereas actually it could be done by 2 bends. So, by optimizing or reducing the bends in the pipeline, a very simple measure. I mean, one can reduce the pressure drop across the pipeline, and in this case, I mean, it could reduce the pressure drop not by this arrangement, not at one place but at 2 3 places by half a bar. So by half a bar reduction in pressure translates into about 3% saving of the compressed air energy. So I mean, it's quite a bit of saving without any kind of, and they implemented this immediately after our, and this is before and after kind of case after we identified this. Now, this diagram actually again shows the piping. Now, bad piping basically of a compressed air line where the tappings are taken from below underside of the main piping, and uh, essentially the reason why it is bad is because you will have moisture also coming in. If wherever you will have some amount of moisture in the compressed air, it can come into the equipment and get into the equipment. The piping here, as the photograph other shows, is actually should be taken from the upper side of the main piping, so to reduce the moisture coming into the equipment along with the compressor. This is a very simple arrangement. Now, another typical mistake in compressed air pipeline is having underground piping. And as this photograph shows here, after the receiver, it goes straight away underground. Now, I mean, if you have it underground, then even if there is leakages because of the corrosion of the pipeline, after a few years, you'll never notice it. So this is to be avoided, and it should always be overground piping for compressed air network. Now I'll come to another case study on compressed air system. This is again taken from an actual plant, which uh, this is a plant which is actually quite a large shed. Actually, the distance between the paint shop and CNC and the main process area, the molding, sand molding, maybe about 800 meters or so. It's a huge amount of pipeline, as you can see, and they were having 3 air compressors, 22 kilowatts and two of 55 kilowatts, and it is all connected through the main system. Now, typically in this, and as you can see, the piping was GI. Typically, that is what most plants do, GI piping. What essentially you can see, this was the after situation. One of the recommendation here, as you can see, was using aluminum seamless pipe instead of GI pipe. And aluminum seamless pipe is, leads to less amount of pressure drop in that. The other thing which you would have noticed before and after situation is to have a ring closed loop system. So this is actually close the loop. Earlier it was not a closed loop system, so it is actually close the loop. And then the third measure in this plant was to have the 22 kilowatt compressor connected because to an independent load. So basically, instead of reducing the pipe because it's a long pipe, so the 22 kilowatt air compressor is only catering to the paint shop and a certain section, and the larger compressor, the 55 kilowatt, is only catering to the main process. So it's segregating the process loads and the auxiliary loads. This is another third recommendation. And this particular measure actually reduced, one of the compressors, 55 kilowatts, was shut down in the plant, and it led to about 2,300 units kilowatt hour of saving uh, per day in that plant, which is a huge amount of saving. Now I'll just there's a one question which I'd like to maybe share with all of you, and the question is from Mr. B. N. Gupta, and Mr. Gupta, who has asked about, is there any instrument available for leakage detection which can be installed, basically if there is any instrumentation for ear leakage detection. So thank you for your question, Mr. Gupta. Actually, uh, there are many instrumentations to detect ear leakages, mainly ultrasonic. All are ultrasonic. To, I mean, essentially to detect ear is leaking through that. It's ultrasonic. On ultrasonic principle, you can hear a sound and go towards that. But our practice shows it is easier to detect. I mean, instead of using instrumentation, it is more easier to detect air leakages when the plant is under shutdown. Either it's the machines are under shutdown and you operate the air compressor, and if it's at night or on a holiday, you can actually hear all the leakages with simply by it. It is audible. You don't require a special instrumentation for detecting air leakages. One can do it very easily. I mean, it's without any instrumentation. Also, although specialized instruments are available. Yeah. Now moving on. Now I'll give you another example of where one can save energy even without a single, I mean, rupee of investment. Here again in a air compressor, every air compressor has got a air filter, and as you can see, like most all engines and also would have a air filter, and simply by cleaning the air filter at regular intervals, like would reduce the pressure drop across the air filter and lead to save energy. And typical time, although every air compressor manual would give you recommendations to save, when to clean the air filter and so on, essentially the rule of the thumb would be every 15 days to take out the air filter and basically clean it with compressed air or the blower kind of thing, handheld blower. And it can be actually used and to save energy very simply in the plant. Uh, Now this is moving on to the example of energy saving by changing air filter. Now here, particularly in this example, usually air cleaning of the filter is sufficient, but if the filter was worn out, so it was actually had to be replaced here. And typical rating of the compressor is given 121 CFM. Now, what was the rated CFM? The rated CFM of the air compressor and every specific energy consumption was 0.17 kilowatts kilowatts of energy per CFM. That was the rated. But the operating efficiency of the air compressor, this was measured, was found to be zero point 0.2 instead of 0.17, and the compressor was operating at 87% loading. That is the loading kind of thing. Now, because of the higher, because the pressure drop in the air filter, the energy loss, about 3 units were taking place every hour. Every unit, so this was translating into almost more than 1 lakh rupees, 1.46 lakhs energy cost implication. That was basically which was saved by replacing the air filter. with the minimum investment of 10,000 rupees, as you can see. So payback is immediate. I mean, immediately. So there is hardly, I mean, within a month, the payback was there for replacing of the air filter. Now, another compressor. This is obviously an investment measure, not a free, not a best operating practices. Is to downsize the compressor. One thing which you need to remember is that for any air compressor, it's need to be operated at maximum loading. I mean, usually it should be loaded 75-80% of the time. But if it's like usually when we found that in the audits, people purchase a larger size of air compressor. So maybe the loading of the compressor only 50% or 60%, 70%. Like it is never loaded to 80% loading, which the compressor should. So this typical example is changing an oversized compressor with a smaller compressor. And existing FAD, as you can see in the plant, was 12.17 meter cube per minute. That sorry, the design uh, volumetric volume of the compressor. The demand in the plant was 5.85 compared to that meter cube per minute. Now we suggested the unit to replace the air compressor with a smaller air compressor about which is having a 8 meter cube per minute. Why 8 meter cube unit? Because at certain amounts of time the peak air consumption was going up to 7 meter cube per minute also. So there was a peak demand at certain point, although the average was about 5.85. So with this, the investment about 13 lakhs, the energy saving simply in the air compressor was almost to the tune again almost 12.8 lakhs to 13 lakhs of uh, saving, and also the payback is within a year. So huge amount of savings because the loading, because could anybody know why? I mean, why the energy was wastage if it's underloaded compressor? Because underloaded, essentially what happens is during the unloading time, the motor is still drawing a large amount of current. Almost, I mean, 40% of the current is still drawn during the unloading time also. So, I mean, it is not doing any effective work, but still using energy. So that is the principle of either you downsize the compressor or one can install a VFD, and I'll come to a VFD retrofit also for compressors which are loaded below 50% or below 60%. It can actually save energy by simply installing a VFD along in the compressor, if it's possible, of course. Now, another example of saving energy is automatic power factor correction system. This is also, I mean, some the units, particularly in UP, which is having the billing is based on KVAH, so it is not based on KWH. So there, the power factor becomes very important and very critical. As you can see, the earlier the billing power factor was 0.975, 12-month average, and the amount of energy units which was built was 3.32 million kVAH. Now after, and you can see what they had before, some sort of capacitor bank, obviously, which was not taking the power factor to 0.999. So with installation of a new automatic power factor correction panel, as you can see, they can maintain 0.999, and the amount of build units have come down to 3.25 million kilowatt hour kVAH, sorry, and the saving electricity bill has is about 4.7 lakhs per year with an investment of equivalent amount 4.85 lakhs. So this is a very simple tool to save energy immediately in the plant through power factor correction wherever the billing is based on this. Now coming to hydraulics, I'll come a little bit because many of you are into things like press shocks and machines and so on, and where energy can be saved by having better drives with the motor. Uh, the first example here, I mean, there are two ways of saving energy in these kind of motor-driven systems. One is either using a soft starter with a capacitor, and the second would be a VFD. I'll give both the examples from that. Now, use of soft starter. Now, the graph on the blue, this is without any control, without any soft starter or capacitor bank. And as you can see, there are peaks. There are peaks in that. So what essentially a soft starter does is that peak load is cut down, and the red line is what is after the installation of soft starter and capacitor bank. That is, we have recorded this actually before and after cases, and that you can see the red line actually. That is how the power curve is after you have a soft starter and capacitor bank, which can actually, and the basically the area between those two is the power saving. So this is a huge amount of power saving, and also the peak power reduction which can happen through that. The second measure could be a VFD, installation of a VFD, variable speed drive. This is obviously a more costly option, but it has better control. So this graph, the red graph, actually shows the power curve before installing a VFD in the conventional hydraulic press. And this is quite a large press. Actually, you can more than 400 tons of press, and you can see the power peaks in the power cycle. Just see this power curve, and after installation of the VFD, what has happened to the power curve. So this was before, and this is after. So whenever the pressure is not on in this on in the on the sheet, it has basically reduced the power to almost zero, near zero, with the frequency control. An average power needed in this is 25 kilowatts, and previously it was 38 kilowatts average power needed in the conventional system. So this also is a very good option, at least for bigger kind of machines, installation of VFD in the to control the power consumption, and it can typically reduce energy consumption by almost about 30% from the conventional. Now, optimizing DG set, loading of a DG set, and I'm sure most of you are using DG sets now. And now DG set essentially becomes very inefficient when it's underloaded. As you can see from this graph, look, when the rating is below 50%, when the loading is below 50% in the DG set, the energy consumption, specific energy consumption becomes very high as the graph very steeply rises. The preferred range, which is indicated, is to load a DG set 60% to 100%. So the selection of the right size of the DG set becomes very important. If like for air compressors, this is again a very important. One should not have a larger size thinking of expansion for the future. Now, I will move on to giving some examples of retrofits or revamps, or basically installing new pieces of equipment to save energy. This is now motors, electric motors. Now, this is a most important. Where most of the people lose money is to have a motor, standard motor, conventional standard motor operating at, and whenever the motor burns, they will rewind it. Right. So, this is before situation. The first photograph shows basically the motor which was there with the, so standard motor, 52.5 kilowatt rating, and has been actually the operating efficiency of this motor was 85%. Actually, what we measured, although the standard motor should have a design efficiency of 91.7% of this size, it was 85% because it has been rewind at least twice. So we recommended the unit to go for IE2 motor. Of course, IE3 also could be there, but as you know, there are different classes now. This is more energy efficient. IE2 is the more energy efficient motor. It's having a design energy efficiency of 93.5 compared to 91.7 for a standard motor of the similar size. So at that, the power which was required to operate this, the power this is measured, was 47.8 kilowatts. The investment in the motor was about 90,000, and the energy saving, the cost saving was more than 1 lakh 35,000 rupees was saved per year. So the payback was immediate. In fact, after we recommended that unit, they installed this motor, pretty immediately. And The other thing was they installed, apart the flat V belts, they changed it to, we recommended, and it was changed to clock V belt, which is also, improves transmission efficiency, the clock V belt as well. Now we could have also gone for i3 motor. In fact, we recommended i3 motor, which is more expensive. Investment would have been about 1.5 lakhs for i3 motor. I mean, almost 1.5 times of i2 motor. But the payback would be 2 to 3 years. But the unit decided to go for i2 motor in this, for this particular case. Now this is an example of a replacement of an inefficient electric oven in a capacitor unit, basically with an more efficient electric oven. Essentially, what the new sorry, yeah, what the higher efficiency electric oven has got an advanced temperature controller. So essentially, that is one of the key aspects. And tell you before situation, it is a 3 kilowatt rated furnace having about half HP blower. Specific energy consumption was 3.23. This is kilowatt hour per thousand capacitors. And after installation, the specific energy came down to 2.66 kilowatt per thousand. But to give you a magnitude of the energy saving, it saved 5,000 units of electricity, 5,145 units of electricity per year at that. And so basically the payback on the investment of 89,000 was paid back within 1.5 years by the replacement of this. So this, after the energy audit, they installed this more efficient furnace and got a very good energy saving. Now this example is again very commonly found in SME, inefficient air compressor. Now the one before that, as you can see, it's again a smaller air compressor, 36 CFM, 36 CFM air compressor. The specific energy consumption in this air compressor, which was measured, was 0.31 units of electricity per CFM. Now, typically, I mean, the new air compressor, which was recommended, as you can see, has a specific energy consumption of 0.22 units of electricity per CFM. It's a LG air compressor. So energy saving was 18,450 units of electricity per year. So basically, the investment of 2.4 lakhs in the air compressor was paid back in 2 years. And this was also installed immediately after, almost nearly immediately after we recommended, and this is the before and after situation. Now, a simple thing like a pump could save a huge amount of energy. As you can see, I mean, this particular factory has, I mean, there's two pumps side by side, one, the new pump and the old pump. And what was wrong about the old pump? Basically, it was having a high energy consumption. It was an old pump, 7.5 horsepower rating, efficiency of 37%. Design efficiency was 37% of the pump, operating at 25%. We measured it during the audit. Only 25% efficiency of the pump. It was replaced with a Grundfos pump, which is having stainless steel impeller. So instead of 7.5, we replaced it with a 5 HP pump. And essentially, as you can see, the energy saving 4.71 units, it reduced to 2.74 units of electricity. And if you multiply this by 24 hours, because it was almost running 24 hours, 300 days in a year, and if you take the cost of electricity to be 6 rupees, a saving of about 85,000 rupees saving. So this is the amount, 85,000 rupees saving in the electricity at an investment of 1 lakh rupees. The payback is just about 14 months, just about more than a year. The investment in the pump, the new pump itself, although the investment is 1 lakh, it pays back within a year, and after that it is free. So this a very simple measure, by replacing the pump with an efficient pump, or a motor with an efficient motor, with an efficient air compressor with an efficient air compressor, leads to huge amount of saving. Now this, I will move on to application of variable speed drive, and this is actually in a compressor. Now what essentially a VFD does, I mean, essentially, as you can see, the air demand is varying. In the plant, there's a peak demand and as less demand. So if it is a varying load, so essentially without VFD, the energy consumption is decreasing, but obviously you can see it is only decreasing by a small amount. By using a VFD, you can reduce the no load power consumption and make the energy curve follow the compressed air curve, as you can see very closely. So if the compressor is loaded higher, you are using higher energy. If it is when it is underloaded, you are using lower amount of energy. Now, this is the photograph of the VFD which was installed in the compressor air panel after the suggestion. This was the result which is got. Basically, the compressor capacity was 112 CFM, loading power consumption was 20 kilowatts, unloaded power consumption was 7.4 kilowatts. So this amount of unloaded power consumption essentially one is eliminating through installation of VFD. Loading period is 51% only. The compressor loaded 51% of the time, unloaded period 49. Energy saving in units per year is 21,765 units of electricity, and it essentially leads to monetary saving of 1.46 lakhs per year. Investment on the VFD is 1.25 lakhs, and the payback is just 10 months. A very attractive option. But here a word of caution about VFD retrofit. It cannot be done for all air compressors. So you have to consult your air compressor manufacturer. Essentially, these are for screw air compressors only. And after you consult, then because of some of the older models, the VFD cannot be retrofitted. Only the newer models it can be retrofitted. Otherwise, if you are going to purchase a new uh, air compressor, then definitely it is worth to look for a air compressor having a VFD control, screw air compressor having a VFD control also fitted in. Now, air conditioning. This is a simple example for air conditioning in a plant which was essentially used for space air conditioning. One of the process areas had to be cooled, and they were earlier having this kind of split air conditioning system, as you can see on your the LG system with the split air conditioning. It was installed, it was changed to a variable refrigerant flow, VRF, variable refrigerant flow system, or it's also called variable refrigerant volume, VRV, is essentially the same term. Refrigerant flow, essentially the cooling load is dictated by the amount of refrigerant flow in the system. And by changing this is about a 15 TR air conditioning system. Power consumption was, as you can see, 37 kilowatts. So it was 2.4 units per TR. That was the consumption. And proposed TR was again same 15. But specific energy consumption in the VRV system was 1.1. As you can see, it's a huge amount of saving. So essentially 1.1 one can get with the best VRV system which is available with Daikin. Some of the other manufacturers normally have slightly 1.4, 1.5 kind of kilowatt hour consumption per TR. Energy saving per hour 20.7 units. Monetary saving per year almost 10 lakhs. Investment in the new VRV system was 6.5 lakhs, which pays back just within 8 months. So although the VRV system is expensive for compared to conventional systems, it has a very attractive payback, as you can see from the calculation. This was also installed in that plant, and they're operating successfully. Another very common example, I'm going towards the end of the thing. So this is basically a transformer. So this is basically a on-load tap change transformer, which was recommended to the unit. Now, one of the reasons for having this online tap change transformer was on-load tap change transformers was the voltage variation. There was substantial voltage variation. You can see 383 volts to it went up to 452 volts. Essentially, at night it will be very high voltage. Day typical of many of the industrial areas within India, whereas you require 4.415 volts. So there is huge voltage variation in the input. Now, because of this, it puts stress on the motor because of the less amount of whenever the voltage is less stress on the motor, and there will be motor burnout. This was the issue. Apart from, I mean, apart from the energy saving, there was a typical issue of motor burnout in the plant. So what a on-load tap change transformer essentially does is it's like basically automatically on load it changes the tap in the transformer. You don't have to do it manually, so that it adjusts the output voltage to nearly what is desirable, 4.415 volts. And this is the transformer rating: 1000 kVA. Energy consumption, annual energy consumption in the unit. Now percentage energy saving because of installation of this transformer, only 1.5%, but in terms of units, 64,000 units of energy saved at an investment of 14 lakhs. The cost saving, cost investment was 14 lakh, cost saving was about 4 lakhs, payback period of less than 4 years, 3.6 years. But more importantly, it having a better quality. So you don't have to have a voltage stabilizer regulator, which becomes more and more expensive. So you can actually do this through the installation of this kind of transformer. Now, moving to another equipment, which on the DG side, of course, I mentioned about the loading in the DG set is important. Essentially, one of the critical parameters in the DG set is specific energy generation ratio, basically specific energy consumption. That is essentially means how much units of electricity you generate per liter of diesel. And this essentially the specific energy consumption one has to compare with the design value of the DG sets. What you are getting now, it can be recorded and compared to the design. And if it's below 80% of design, it is recommended to consult the supplier of the DG sets itself for that. Now this is an example of an inefficient DG set replaced by efficient DG set, because of course here it was beyond uh, repair. As you can see, the condition of the DG set was very poor. This was the rating, 35 kilowatt kVA rating, operating 6 hours per day, essentially in UP where the power electricity is in short supply. And SEGR consumption, again specific energy consumption, was 2.39 units of electricity per liter, 2.39. Whereas the new SEGR, you actually the one after replacement, this is with a higher sized DG set, because they required for other loads also, was 3.75, 3.75 units per liter compared to 2.4 units per liter earlier. The cost of electricity reduced, as you can see, from 20 rupees per unit to 13 rupees per unit, but through DG set. Energy saving was 36% and payback period was less than 3 years. So this is also installed with a new DG set and operating in there. The final case study is about lighting. Now, about lighting, this case study is basically use of mercury vapor, use of induction lamp instead of mercury vapor lamp, essentially for outdoor lighting, sometimes also for indoor lighting within the plant. Now, these are the fixtures. The middle one is actually the induction lamp, very high efficiency lamp, bit expensive, but as you can see, actually the typically the mercury vapor lamp here is 250 watt rating, whereas the induction lamp of equivalent lumen is 150 watts rating. So straight away 100 watts can be saved. The cost of a mercury vapor is about 1300 for this size, whereas similar cost for induction is 8500 per lamp. But the life of the induction lamp is 8 to 10 times more than the mercury vapor. So essentially, even if the price is 7 times more, the life is 8 times higher, and also the energy saving, which I'll show you in the next slide. Mercury vapor lamp, 250 watts. This is the lumen per watt efficiency, 45 watts lumens per watt. The number of lamps in the plant was 10. We recommended to be replaced with induction lamp for 150 watt rating. Luminous efficiency per watt, 150. Very high luminous efficiency compared to the 3 times that. Energy saving was per hour was 115 watts. Monetary saving per year was 65,000 per year through this replacement. Investment about 1 lakh rupees for all the 10 lamps. and simple payback of less than 2 years. That again a very attractive option. Replacement of induction lamp for the replacement of mercury vapor lamp with induction lamp. Here again, I would like to mention on the lighting, that LED lighting, because of course LED is now come into the picture. Now LED lamp typically are very efficient, but they are having a life of 50,000 work hours compared to 80,000 or to up to 1 lakh hours. So induction lamps are having higher life than LEDs also. LEDs are good for indoor lighting or in lighting in clean environment, but when if it's outdoor or typically a very polluting environment or where particulates are there, dusty environment within the plant, then there may be deposition of the dust on the fins of the LED lamp, which can raise the temperature of the LEDs, because the light emitting diodes need to operate at certain temperature, higher efficiency. Yeah, there's a question from Mr. Gupta only about comparison of induction lamp with LED. I'm actually dealing with that presently. I can't see the question right. Okay. So the LED lamp, as I mentioned, is a good for clean environment, but induction lamp is typically good for outdoor and for factory with particulate, because the fins, when there's the deposition on the fins come of the particulate, then the heat transfer will reduce, and there is chances of LED failure faster than the light. So from that point of view, I mean, it depends a lot on the application, but LED induction lamp is a very proven technology, and it is also manufactured within India. So like there are Philips also manufactures it. Mahindra in Hinole has got his plant to manufacture induction lamps within India. So there are two. So this, please look at this option also, particularly for outdoor and even for many of the indoor applications, use of induction lamp, and I'm sure it will be fruitful for you. That is all I wanted to convey to you. I think I've spent more than 1 hour, and this is the contact details, my email contact details at TERI, and please feel free to write to me or to Tata Steel about any queries you have on energy efficiency and energy saving. And thank you very much for your patient hearing. Thank you very much. If you have any questions, feel free. Although I may not have missed out some of the questions you may have had, but you can always email me, and we'll be happy to share with you whatever we know. Thank you.